welcome to my another lesson. Today we will study about the description of motion in two dimension. So in this lesson we will study the description of motion in two-dimensional plane. That means a Cartesian coordinate system consists of x-axis and y-axis. So as a preliminary idea of the lesson, so let me go into two terms. One is vectors and another one is scalars. Vectors and scalars. So most of you may be knowing what is a vector. So vector is a physical quantity having both direction and magnitude. So I can write vector is a quantity having both magnitude and direction. Examples are velocity, acceleration, momentum, etc. Now what about scalars? Scalars are those quantity having only magnitude. So scalar is a quantity having only magnitude. It does not have a direction. For example, mass, volume, time, etc. are examples for scalar quantities. Now let me go in detail to the vector analysis. So vector in two dimension. So let me consider a vector. For example, I am considering vector OP. So a vector will be denoted like this. OP, I can use two English alphabets along with one arrow mark. That means this quantity is a vector. Now if I mark this vector in a Cartesian coordinate system, I will be using both x-axis and y-axis like this. So this is my x-axis and this is my y-axis. So my vector will be like this. So this is called the vector OP. If O is the coordinate and P is a position in Cartesian coordinate system, that is a point in an xy plane. So OP is my vector. As I told you that vectors have both magnitude and direction. So magnitude means the numerical value of that physical quantity. Now how to represent a vector? So for example, a vector PQ will be represented like this. This is my vector PQ, okay, and this is the tail of the vector and this is the head of the vector. So I can write this vector like this, that is vector PQ. So vector PQ means it is a physical quantity having both magnitude and direction. For example, velocity. Now what is unit vector? Unit vector means a vector divided by its modulus is called the unit vector. That is, unit vector is normally denoted like this, a cap. If A is a vector, then A cap is a unit vector. So vector A divided by its modulus. So modulus means its magnitude. Okay. So I can write it as vector A divided by its modulus. Modulus means its magnitude. Is called the unit vector. Now equality of vectors. Consider two vector, this is a vector PQ and another vector RS. So if vector PQ is equal to RS, then it must have both the same direction and same magnitude. Okay, for example, PQ, vector PQ is equal to vector rs if and only if both should have same magnitude and direction. Here you can see that the length of vector PQ is same as to that of the length of the vector rs, and both are having the same direction. So we can say that vector PQ is equal to vector rs. P and vector Q are equal. P and its magnitude is 5 centimeter, and this is vector Q and magnitude is 5 centimeter. Now my question is whether P and Q are equal, or can you consider these two vectors as equal? The answer is no. Even though it has the same magnitude, direction is different. So we cannot consider these two vectors as equal vectors. Multiplication of vector by a scalar. So next topic is multiplication of a vector by a scalar. So here I have a vector OB I am considering. OB is my vector shown like this. This is OB. So I am multiplying this vector OB with a particular constant. For example, it can be for 2. So 2 into OB will be what? What will be the 2 times of OB? And how can you represent that vector? So 2 into OB means nothing. The direction will be the same, but the length of the vector will be that constant times the length of the original vector. So here you can see that I have multiplied with 2. So my vector should have 2 times the original length. So I can represent the vector like this, and again it is OB. So OB and another vector. So I can write it as the new vector as 2 times of OB. So the given vector that you can see is a vector which is multiplied with a constant. Always remember, whenever you multiply a vector with a constant, the magnitude will be only changing, the direction must be the same. But when you multiply with a negative number, then in that case the direction of the vector will be changing. For example, I am multiplying the vector OB with minus 1. Okay, so I am writing it as OB, vector OB into minus 1. So what will happen? This will be minus vector OB. So minus vector OB means what? It is just a reverse of the previous vector. For example, if this is OB, and OB has a length of 5 centimeter, then minus OB will be like this, minus OB. The magnitude will be the same, 5 centimeter, but the direction has changed because magnitude is 1 only. So the only quantity which is going to change is its direction. Now addition of vectors. Let us consider two vector A and vector B. It can be of velocity and acceleration or whatever it is. So I am going to add these two vectors. So when you add these two vectors, then the sum of these two vectors is called as the resultant of vector. Resultant of these two vectors. Resultant of these two vectors. So resultant, I can write it as vector R. So vector R is equal to vector A plus vector B. So what is the physical significance of vector A and vector B when you add together, it is nothing, just we are adding its magnitude, and direction will depends upon the direction of the original vectors. Let me consider an example. Okay, our next topic is addition of two vectors. So here I have taken only two vector. You can use 3 vector, 4 vector, or n number of vectors. There will be no problem. But for the sake of explanation, I am taking only 2 vectors. So vector can be added in two different way, especially the case 1 when 2 vectors are acting in the same direction. So let me write it in the same direction. Okay, so let us consider 2 vectors, vector A and vector B. I am going to add these 2 vectors. So the sum of these 2 vectors are what we call as the resultant, is denoted as vector R. So I can write it as vector R is equal to vector A plus vector B, and this is applicable only when these 2 vectors are acting in the same direction. If they are acting in opposite direction, or if they are acting in a particular angle, then the result cannot be used. So let me consider the physical example of the addition of these 2 vectors when they are acting in the same direction. Here you can see 2 boys. Both of them are pushing a wooden block towards a particular direction. So the force applied by the first boy, I can write it as F1, and the force applied by the second boy, I can write it as F2. Since both are in the same direction, the effect of these 2 forces will be the sum of individual forces, as you know it. So total resultant means total force F is equal to vector F1 plus vector F2. And remember, the resultant of these 2 vectors will be also another vector, third vector, because both the boys are having the forces. So when you add 2 forces, you will be getting only the force with the same dimension. So this is an example for addition of 2 vectors in which the direction will be the same. Now let us consider the addition of 2 vectors when they are 180-degree angle, means they are just pushing in opposite direction. So then what will happen? So in this case, the angle between these 2 vectors will be 180-degree, and the resultant of these 2 vectors is a new vector whose magnitude is the difference between the magnitude of the 2 vectors and whose direction is the same as the direction of the bigger vector. So let me consider a vector. This is my vector, vector A, and another vector, vector B. And imagine the vector A is greater than vector B. So I am writing vector A is greater than vector B. So when I am taking the resultant, that is vector R is equal to vector A minus vector B. Now the direction will be the direction of the bigger vector. That means the direction of A. The resultant's direction will be the direction of A, and magnitude will be the difference of these 2 vectors. So again, let me consider another example which can be used to illustrate this situation. Let us consider a situation like this. Here 2 boys are pushing a wooden block, and imagine the boy A has more force. Let it be FA. FA is greater than FB. So FB is the force exerted by the second boy. So when both of them are pushing each other, so what will happen? the box will be moving to the direction in which the greater force is applied. So here you can see that the force due to the first boy is higher, so definitely the box will be moving towards the right side since Fa is greater than Fb. Now what will be the effective force? The effective force will be the difference between Fa and Fb. So I can write it as the direction will be the direction of the force and the magnitude Fa minus Fb and is towards a right side. Difference between two vectors. And another case, when two vectors are inclined to each other. So in the previous cases we have studied that the addition of two vectors when both the vectors are acting in the same direction. Now and after that we have studied when two vectors are acting at 180-degree angle. Now without 0 and 180 we have some angular deviation between two vectors, like vector A and B. Just see vector A, this is vector A, and I have vector B, and which makes an angle theta like this. So what will happen? So here angle is not 0 or it is not a 180 degree. So if it is a 0 we can write it as A plus B, and if it is a 180 degree then we can write it as a minus B. So here it is not a 0 or 180. So in this condition what is the another method? So here we will be using two different methods. They are what we call as the triangular law of vector addition, and another one is parallelogram law of vector addition. So let me tell you what is a triangular law of vector addition. This is vector A and this is my another vector B. Okay, so I am going to add these two vectors, then the sum will be vector C. So I am writing this as a sum of these two vectors. So I can write vector C equal to vector A plus vector B. Okay, so here the meaning is very simple. For example, you just consider you are standing here, okay, and you wish to go to your school, and your school is here. Okay, so you have two roads. One will be the road directly which is going to your school, and you have another road which will be going through this path, okay, through A, and then it will be going to B. So what is its meaning? So if you travel through A and B, then also you will reach your school, or if you go directly through the road C, also you will reach your school. So its meaning is very simple. So A and B means A plus B is equal to C. That is only its meaning. Okay, so I am writing is vector C equal to vector A plus vector B. Okay, so let me state what is the triangular law of vector addition. So triangular law of vector addition states that when two vectors are considered as the two adjacent side of a triangle, then the third side of the same triangle will be the resultant of these two vectors taken in an order. So what is that last sentence? The taken in an order means here you can see that two vectors, vector A and vector B, are connected in such a way that the tail of the vector B is connected to the head of the vector A, means a head to tail connection. So you cannot take like this, means this is the tail, this is the head of the vector A, and this will be again the head of the vector B. So this is not possible. So this is taken in reverse order. So here we have to take in an order, means order should be the same. That means if this is the head of the vector A, then the tail of the vector B must be joined with the vector B, and this will be the sum, and the tail of the vector C must be joined with the tail of the vector A. You can see that these two vectors are just like starting from the same origin. So if O is the origin, so vector A and vector C are starting at the same origin. Then only you can take A plus B equal to C. Otherwise what will happen? So we have to take in the reverse order. There is no problem. So you will be taking the sum of vectors only in a particular order. I will explain it once again. Okay, just to consider another vector or another triangle like this. Triangle PQR. Okay, triangle PQR. Suppose I am taking like this, vector RQ is like this, arrow mark is towards the right side. Now the vector PQ has an arrow mark like this. Okay, now vector PR is represented like this. Now how can you take the sum of these two vectors? It will be RQ, vector RQ plus vector QP is equal to vector RP. Okay, will be equal to vector RP. Similarly, if I am going to consider another case like this, vector L M N. So here you can see the case like this. Now how can you take the sum of these vectors LM, MN and LN? So I can write it as vector LM plus vector MN equal to vector LN, because vector LM and vector MN are taken in head to tail position. Okay, so this is what we call as the triangular law of vector addition. So once again I am telling, triangular law of vector addition means when you want to add two vectors, then you consider these two vectors as the adjacent side of a triangle. Then definitely the third side will be the resultant of these two vectors. That is the triangular law of vector addition. Okay, now we will study the parallelogram law of vector addition. So here also we will consider two vectors as the two adjacent sides of a parallelogram. Okay, and here I have another vector. This is vector B. These two vectors are considered as the two adjacent sides of a parallelogram. Then the diagonal, I am just drawing the diagonal. So diagonal will be the sum of vector A and B. So I am taking vector C as the resultant of these two vectors. Then vector C is equal to vector A plus vector B. I am writing. Now I can complete the parallelogram like this. So vector A and vector B. Now just to see, vector A is represented like this, the bottom side, and vector B here this is my vector B as I have drawn. Now this dashed line is also parallel to the vector B. So I can replace that dashed line with a vector B. So this is also a vector B. Okay. So now it is just like our triangular law. Vector A plus vector B equal to vector C. That's all. Now if I just redraw the diagram for the derivation of some other quantities. Extrapolating vector A like this and one perpendicular towards the extrapolated portion of vector A from here, and I am going to consider theta as the angle between vector A and B. What is theta? Angle between A and B. So this is my angle theta. Okay. So this will be also theta. This will be also theta. Now if alpha is the angle between vector A and the resultant of A and B. What is alpha? Is the angle between A and the resultant of A and B. Resultant of A and B means it is a C. So theta is also marked here. Now from the triangle, let me draw numbers like this is P, this is N, and this is R, and taking it as Q, and this is O. So O, P, Q, R, N. So from triangle PNR, actually triangle PNR is a right angle triangle. So sin theta I can write it as, sin theta is opposite side Rn divided by hypotenuse. So hypotenuse is vector B. So basically this is vector B. So Rn by vector B. So Rn will be Rn, I can write it as B sin theta. Rn is B sin theta. So I am writing Rn here as B sin theta. Rn is B sin theta. Now as per the rule from parallelogram law of vector addition, the magnitude of C I can write it as, the above diagram I am just redrawing here. This is my vector A up to this, and this is sum of these vectors. Okay, just I have redrawn the diagram. So as per the law of parallelogram, I can write the magnitude of C. That is magnitude of C as C is equal to root of A square plus B square plus 2AB cos theta. Now how this comes you will study later. But you just by heart magnitude of C. C is root of A square plus B square plus 2AB cos theta. A, B, C are vectors and theta is the angle between vector A and vector B. Now from the triangle RPN, I have already found that Rn is B sin theta. Now On I can write it as On is equal to sum of this, that is vector A plus Pn, that is vector A plus Pn. So from this triangle, if this is B sin theta, then definitely this will be B cos theta. This will be B cos theta. So I can write On as vector A plus, what is Pn? Pn is B cos theta. So why this B cos theta comes? Because from triangle PNR, cos theta is equal to adjacent side. Adjacent side is Pn by hypotenuse. Hypotenuse PR. So PR is our vector B. Okay, so vector B. So Pn equal to vector B cos theta. So that only I have written here, vector B cos theta. Okay. Now from the bigger triangle ORN, from triangle ORN, what will be tan alpha? Tan alpha will be opposite side divided by adjacent side. So my opposite side is B sin theta. So B sin theta. So this will be the big triangle ONRO. So in this triangle, opposite side is Rn, which is B sin theta. So B sin theta divided by adjacent side. Adjacent side is On. So On already I discovered here, which is vector A plus vector B cos theta. So this is also vector B. Okay. So tan alpha is B sin theta divided by vector A plus vector B cos theta. That means alpha is equal to tan inverse of vector B sin theta by vector A plus vector B cos theta. Don't afraid of tan inverse. It is nothing. It is just a mathematical step. For example, tan 30 is equal to, if tan 30 is x, then 30 will be always tan inverse of x. That's all. Or once again, sin, what is sin 90? Sin 90 is 1. Then 90 will be sin inverse of 1. That's all. So here alpha is equal to tan inverse of vector B sin theta divided by vector A plus vector B cos theta. Now in the above diagram, the above equation for C is equal to root of A square plus B square plus 2AB cos theta. I am just rewriting the above equation. If theta is equal to 90 degree, what will happen to the above equation? So C will be A square plus B square plus 2AB cos 90. Cos 90 will be 0. So finally C will be root of A square plus B square. Now just square the above equation on both sides. So you will have C square is equal to A square plus B square. So this is our Pythagoras theorem. So Pythagoras theorem is applicable only for right angled triangles. That is, if I draw a triangle like this and this is A and this is B, then C will be the hypotenuse. So hypotenuse square is equal to base square plus altitude square. That's the only thing.